Hello, welcome all to Anudeep YourStudyBuddy. Today we are going to discuss about the topic linear programming problem. It is very easy to score marks in your board exam on this topic. This topic carries 4 to 6 marks in your board exam. So let us understand few basics before we proceed. Linear programming problem consists of finding the optimal solution for the given linear function. So in this problem, you will be given the linear equations for the specific problem under consideration, and with the constraints imposed on these different linear equations, you will be finding out what is the best solution. So here when we are finding out the best solution, we follow the concept of convex set. Convex set is nothing but a set of points in a plane where the segment joining any 2 points of the set entirely lies in the set. So you can see on the screen there are figures given. So when you are finding out the solution for the LPP, we are looking for the convex set, and that can be obtained by finding out what are the corner points joining them and finding out the feasible region for the given problem under consideration. Finding out the convex set for the given problem, you may come across a solution where the convex set may be bounded, as you can see the figure 7.2 and 7.2b, and it can also be unbounded like it is shown in the figure 7.3a and 7.3b. So where we see that when we are talking about the solution or feasible region, satisfied by all the constraints, if you are having a corner point where the feasible region is enclosed, then the convex set is said to be bounded. If it is not enclosed, if you cannot occupy all the constraints satisfied by the given linear equations, sometimes you may come across the unbounded region. Before actually proceed to find out the solution for the given LPP, let us understand what is the graphical representation of the equation or inequation given in the problem under consideration. So here, if I want to represent any line on a graph, for example, if I have the constraint or the inequation as x less than or equal to h or x greater than or equal to h, as you can see on the screen, when we are talking about x less than h, it is a left hand side. That is what we are going to consider when we are plotting the line on the xy plane. So here when we are plotting the line, first thing is we will be converting inequation into equation, like it will be x equal to h, and the region under consideration will be, because the constraint is x is less than h, it will be the left side of the line. Similarly, if it is x greater than h, we will be considering the right hand side. This is the same concept we can apply for the y-axis as well. So as you can see the figure 7.6 and 7.6 and 7. So this is how we are going to plot the graph for the given constraint. If it x is less than or greater than or less than equal to h, this is the way we are going to follow. Now talking about the graphical representation, as we just now seen, when it involves simply a one variable, it becomes very easy to plot the lines. But if you have two variables involved, like on the screen you can see ax plus by less than or equal to 0 or ax plus by greater than or equal to 0, then we need to find out the Cartesian points for the respective lines, and for that purpose we will keep one variable equal to 0 at a time and getting the value of other. That will give us the coordinate point that satisfies the equation of the line. So here if we have the equation ax plus by equal to 0, we will convert inequation into equation first, and then we will keep x equals to 0 and we will be getting the value of y. Similarly, the second time we will keep y equal to 0, we will be getting the value of x. This is how you get two distinct points, and as you can see, when we want to plot a line, we should know two distinct points. So this is a way we work out the coordinate points to plot them on the Cartesian axis, and we can plot that given constraint depending upon the region, depending upon what is the sign involved in the constraint. If it is less than, it is towards the origin, and if it is greater than, it is away from origin. So this is what we have to keep in mind when we are talking about the feasible region. We need to highlight the point which is towards origin or away from the origin. It is very important to understand which side of the line or the equation we need to consider while we are deciding the feasible region. And for that very reason, it is very easy to consider that we consider 0, that is origin 0, 0 as a test point. If 0, that origin 0, 0 satisfies the given inequation, then x plus by less than or equal to c, then region is on the origin side. Hence, shade the region, otherwise shade the half of the plane H2. The shaded portion represents the solution set of the given equation. So it is very important, this test of origin you can very well apply and see if it satisfies the equation, that point satisfies, that means it includes the origin. So it is toward the origin you are going to shade that feasible region. So it is very important. Let us understand when we are plotting the equations included in the linear inequalities which are defining a particular problem. Suppose we have a constraint called x is less than or equal to 3. So first step will be you convert inequality into equality. So x equal to 3, that is what is the line you are going to plot on xy axis. This is what you see. It is a line which is parallel to the y axis and which is passing through the point x equal to 3. Now the given constraint is x is less than or equal to 3. So as it is less than 3, we will be considering the region which is towards the origin. So this is how we define the feasible region for the given constraint. Similarly, for the second constraint y greater than or equal to minus 2, again the first step will be to convert inequation into equation y equal to minus 2. Now this line will be parallel to the x-axis passing through y equal to minus 2. Now the region is defined by the constraint or inequation, that is y greater than or equal to minus 2. So as the sign is greater, it is above the line that we are going to consider. So it is above the line y is equal to minus 2. That is what we will be defining the feasible region. Here we have to draw the constraint x plus 2y less than or equal to 0. So this is what is the inequation we are going to plot on xy axis. First step will be converting inequation into equation. So it will be x minus 2y, x plus 2y equals to 0. Now transferring 2y to other side, we get x is equal to minus 2y. Now as you can see, it is of the form y is equal to mx. That is, it will be a line passing through origin, isn't it? So here we need to identify the points which will lie on this line defined by x plus 2y is less than or equal to 0. So giving different values to x, we can obtain different values for y. So if I substitute x is equal to 0, we will be getting y equal to 0. When we substitute x is equal to minus 2, we get y is equal to 1. This is how you are going to define different coordinate points which lie on the line. And first by plotting the points on the xy plane, then joining them, we will be getting the required line defined by the given constraint. So here, as the origin lies on the line x minus 2y, we have to choose the another point as a test point to check whether we are going to define the region which is above the origin or below the origin, and it comes out to be minus 6. So that means we have to shade the region below the origin. So this is what the line is passing through the origin, but the region is defined by the portion which lies below the given line. Now let us see how to draw the line 2x minus 3y greater than or equal to minus 6. So first step, as you know, we convert inequality to equality. So it will be 2x minus 3y equal to minus 6. Now we need to work out the coordinate point for which we get the equation, which equation gets satisfied. So for that very reason, to get two distinct points, we equate one variable equal to 0. As you can see, first time we are equating y equal to 0. we'll be getting the value as x is minus 3. So minus 3, 0 is a point which lies on the required or the given line. Similarly, in the next case, we are going to keep the variable x equal to 0. We'll be getting the value of y equal to 2. So now we have defined two distinct points which satisfy the given constraint. Let us plot them. And as you can see on the screen, we have plotted the line. Now we need to shade the feasible region for the given constraint. So we need to define, we have to check whether the origin lies towards it. So as the sign is greater than or equal to 0, we assume that it is the above region that we have to check. But here, as you can see, that 2x plus 3y, when we are following the origin point, when we substitute 0, 0, it is greater than minus 6. Therefore, the required region is the origin side of the line. So, below the line of the region that we are going to shade as a feasible solution. So, it is very important and very mandatory to test this origin test before you highlight the feasible region. When we are solving problem on LPP, what is a convex set? How the unbounded and bounded convex sets are defined? How to plot the given region or the equation or inequation on the Cartesian graph xy plane? That is what we have discussed. We have discussed a simple problem. We have discussed the equation involving one variable, two variables, and what is the method to be followed so that to decide which is a feasible region for the given constraint. So these are the prerequisite to solve any LPP problem given in your board exam. So we will continue with this topic in the next part. So stay tuned. We will be solving more problems on LPP. See you very soon. Thank you very much.